Your body, my body, everybody's body is made from a series of complex organs. These organs are composed of cells. These cells contain organelles. The organelles are made from complex organic molecules. Molecules are made from elements, and elements are composed of atoms. Every object you have ever touched, everything you have ever tasted, has been made from a combination of only 115 elements. It is truly hard to believe that the birds in the sky, the animals in the fields, the chair you're sitting on, the coffee you drink, all are made from a combination of only 115 basic building blocks. Amazing. These basic building blocks, the atom, is the smallest particle of any element that can exist. Let us have a look at one of the most common, that is carbon. Everything on this planet is a carbon-based life form. Carbon has the number 6 in the periodic table of elements. All plants and all animals use carbon as the baseline element around which the architecture of larger molecules are built. A molecule is a group of atoms bonded together, representing the smallest fundamental unit of a chemical compound that can take part in a chemical reaction. Carbon has 6 protons, 6 neutrons, and 6 electrons. The diagram you're looking at is not a real representation of the proportions of an atom. And this part is really important. We need to talk about space. It's all relative. A tiny mouse will find the space underneath your floorboards large and extensive. So what sort of size are we talking about when we talk about the space between atoms and their electrons? The typical radius of an atom is about 1/10 of 1/1000th of a meter. Under most definitions, the radii of isolated neutral atoms range between 30 and 300 picometers. This is a tiny distance, trillionths of a meter. That can also be described as between 0.3 and 3 angstroms. That's a new word, but it's useful in this context. The radius of an atom is more than 10,000 times the radius of its nuclei, and less than 1,000th of the wavelength of visible light. And we'll come back to that later. But this is an incredibly small size. If an atom was the size of a 2-story house, the nucleus would be the size of a barely visible speck of dust. And if you were to truly represent the proportions within each atom, we would show the protons and the neutrons as a marble in the center of a stadium, and the electrons as specks of dust in the seating area. And what is in this space between the marble and the dust? What's in the space between the tiny marbles in the center of the stadium and the specks of dust in the seating? Well, the surprising answer is nothing. Empty space. Nada. Zilch. Diddly squat. It's empty. Amazing. There are literally billions of atoms in the human body. A typical 70-kilo human might contain 7 billion atoms. That's a 7 followed by 27 zeros. It's huge. About 2/3 of these are hydrogen, 1/4 is oxygen, and about 1/10 is carbon. And these 3 elements, they make up 99% of your body. And all of these atoms are almost completely empty. Crazy, right? But the crazy thing about atoms doesn't stop there. Almost all of the density of an atom is in the nucleus, that tiny marble in the center of the stadium. There is a small amount of density in the electrons, but it's negligible, and we can ignore it for now. Virtually all of the density comes from the protons and neutrons that are in the nucleus. So how dense is the nucleus? incredibly dense is the answer. If you took 6.2 billion cars and compressed them into a box that was just 1 foot by 1 foot, that would approximate the density of an atom. So let's review what we learned in today's lesson. Everything is made from atoms. Atoms are made from protons, neutrons, and electrons. The protons and neutrons are in the center, and this is called the nucleus. The nucleus contains almost all of the density of the atom, and it is incredibly dense. The space between the nucleus and the electrons is empty space. There is an incredible amount of empty space. And this space will become crucial in our next step along the journey of understanding radiation and its importance in life and health.